Okay. How are we all doing tonight? Okay, let's see here. Looks like audio is working. Looks like stream health is good. What does it look like here? Is audio working? Audio is working. We love that. Cool. Okay, let's get this going. So, what are we doing tonight? Let me move you all around just a little bit so you can see. Well, maybe we'll go closer and just point you up some. Hi. Okay, that's what we're doing tonight. We're going from here. We're doing a 90. We're coming down this strut. We're coming down here, and we're going to go to a piece of strut that's not here yet. So first thing we're going to do is get that missing piece of strut up. So we're gonna need a drill. We're gonna need a vacuum because we're gonna make some drywall dust. Hey, vacuum's even got battery. We got some drywall anchors. We need a piece of strut, that's important. Well, we got a good looking piece of strut for this. We got some strut, and then we also are gonna need some washers. I think those are in the ladder. Washers are not in the ladder. Well, for those of you keeping track at home, you can start the Adam looking for something timer. Are they right right here? Oh, they're right in front of me. I was looking at it right then. Okay, stop the timer. We got washers. But this should be pretty fast. Just putting one piece of strut up. Let's grab a level. Level's over here. I'm pretty sure level's in the ladder. You know, let's bring the ladder closer, actually. It's a good thing to be setting things on, such as the vacuum. Oh, man. Caught on the tripod twice there. Like a dog trying to bring a stick that's too big for a door through a door. Okay. Let's get this up. So what are we putting up here? We are putting up... Where'd it go? I thought I had it out already. I do have it out already. I just set it over here. Oh. No, I guess I didn't set it over here. I got one of the valves. Where'd the piece I glued together already go? Huh. That's interesting. It was attached to this, and then I started cleaning some parts up so that I could get it. Oh, here it is. It's right in front of me. It's right in front of me. So this is what we're going to be putting up on the wall tonight. Well, we might actually remake this because I'm not quite happy with the glue fittings on this. So it's going to be this, and then it's going to be valve, and then it's going to be another valve. Wherever that other valve happens to be. We're going to need that valve at some point, so I might as well find it now, I think. Oh, okay, here it is. Do we got a short piece of tube we can put in this? Well, I'll just kind of hold it up. So this is what our setup's going to look like tonight. You can imagine the tube that's not currently there. So what is this? This is going to go on the wall like this. Yeah, you know, like that. So our water is going to come down, go through one side, go through the microscope, come back, go back up, and the return. So why is there this valve in the middle? So a lot of the chillers that we're going to be using have, like, specifically the Thermoflex chillers have an insane flow rate, like 40 something liters per minute. And this microscope needs like 0.5 liters per minute. So we're going to take advantage of that high flow rate to maintain really good temperature stability through the cooling loop. But most of the flow is actually going to be bypassed by opening this valve partway. So most of our flow is going to be bypassed, and just some of it's going to go to the microscope. But because we have a really high mass flow rate through the tubes, we're going to maintain really good temperature stability. So that's what's going on the wall. We're probably going to rebuild this part. We need to put some strut on the wall. And then one additional constraint we're going to work with tonight is, so these are the cushioned strut clamps that we've been using. They're really great. The challenge is I only have 8 more of them. I think I must have just used more strut than I thought I was going to when I was buying the strut clips. And I even like bought extra, but you know how it be. So 8 is 4 pairs, right? So we got 1, 2, 3, 4. So we've got enough strut clips to do 4 more mounts tonight. So we're going to be skipping this one. And we're just going to be putting more piece of strut up tonight. We might put more strut up in the future, and also more clips. We're definitely going to put more clips once we get them in on that one, because we're going to skip that one for now. But that one is a little bit extra. Like, we got enough going off what we got here. So what are our measurement challenges going to be tonight? So for the rest of the strut run, the precise distance between the tubes, I've been trying to keep it consistent because I think it looks good. But in this case, we've got this assembly that's going to be at the end here. So this actually does need a certain distance for the tubes to be apart, right? So because of that, we're probably going to start, we'll get this up, we'll start here, we'll work our way up, work our way over, and then we're going to need to kind of get these ones cut to whatever spec we decided to. So the first thing we need to do is decide, are we going to use this piece or are we going to glue a new one up? Well, this part of the first thing we need to decide. The other thing we could do first is put some strut up on the wall, and just to get that mounted, and then this is going to decide kind of where this goes. I'm holding this piece right now, so let's go ahead and inspect the glue joints here and see how we feel about it. I kept these, when I glued this one originally, I did this as like a no clearance, like there's no gap there, right? So the union goes right up against the T. Not a huge fan of how that turned out. I mean, I'm not worried about it being sealed. It's definitely going to be sealed. And like, it honestly looks pretty good. Serviceability in the future is very poor if I do that. If I keep things a little bit further apart, you know, I can like cut things maybe. I don't know. But this also, like this is a very consistent dimension. It's another thing to consider here. Y'all's input is welcome. Should I remake these parts or should I just go with it? I'm getting more and more tempted to just go with it. Oh, okay. Here's, it's coming back to me now. What part of it, what I didn't like. Let me bring a light over. Let me switch you all to a different camera. Oh, hello, Mario. Thank you for joining the stream tonight. So let's see if we can see down inside this thing. Probably go manual focus. Oh, it's kind of focusing. So you can see we've got a gap there because the piece of pipe that went in between everything wasn't quite long enough. So I don't really like that little gap. Crudge is going to get trapped there. And honestly, the rest of the pipe is pretty good in terms of not having small gaps like that. Here, let me move my camera a bit better so I can see it. Oh, there we go. Let's go manual focus. There we go. So that's the gap we got on these parts. I don't really like that. None of the other fittings have got that, so I think we're going to go ahead and remake these. But that's pretty fast to do. Okay, so we've decided we're going to remake these. Man, I love how good the manual focus assist is on this camera. It's really good stuff. Also, do y'all like my ceiling mounted lighting system? It's we're almost working where this is useful. Okay, let's flip back to this. So, we decided we're going to remake these, so we'll do that once we're kind of gluing more stuff up, I think. I think for now, let's get our strut mounted. I like the idea of that. What do y'all say? Want to get some strut mounted? Hang some strut hung. So there is a decision to make, and that's the type of thing I can let take way too long. So I'll try and get it done a little bit quickly. And the decision is, where do we want the valves to go? So my building's thermostat is right here too, so strut your stuff. Oh, you know I'm going to be strutting myself tonight. I got lots of strut to strut with. Okay, that's a crossover valve assembly. This is one of the valves going to go to the microscope. Shout out to Seth F for making this piece of pipe. So I don't think we're going to go above the thermostat. I think we're going to go below the thermostat. Yeah, we'll go below the thermostat. So we're going to clamp onto the pipe kind of in between the two sections here, like so. So let's basically, I guess right there, you know, what do y'all think? Hello, Meow, by the way. Are you not autofocusing? Oh, I turned the stabilizer off. There's the autofocus. Okay, cool. So I could go... like, man, anywhere in here, right? I can go right here. I think right about there. I don't know why. That seems nice. Doesn't that seem nice? I could also go there. We'll go right in line with whatever this line on the textured wall is right there. You can just barely, not at all see on camera. Yeah, so I mean, the cooling lines are not cold. They are room temperature. Like we actually run them, like I set all my thermostats the same, if that makes sense. There's not a lot I can do to keep it very far away from this, and that thermostat's going to be replaced and moved anyways at some point soon. So I'm not. It's already like in a terrible spot. Like one of the heaters is, or one of the registers is literally blowing directly on it already. So the it's already like not good. We're not going to make it any worse than it is already by doing this. And the cooling line, like where I go vertically, isn't gonna affect things very much because it's horizontally. I'm gonna kind of go to the left here because that's what's gonna work the best for the cooling run, and it's what's gonna leave me the most room in the strut. So it's just where I want it vertically. I think we'll go right here. We'll go like level with that thing just because it's there. Well, welcome to the stream, Martin. Happy to have you by. We're hopefully finishing up the strut tonight. I'm excited. Okay. What did I do in this last one? Okay, I think what I ended up doing, because I got this, I had the spacer in here. Let me move the camera so I'm not constantly blocking y'all. There we go. Okay. Strut there. Questions need to answer for the strut is how did I do these last times? I think I had to do... Oh, right. I remember how I marked this out now because I had to have this wood spacer because you see there's a slight difference in height here. There's definitely a story about why this drywall here is like so different. This is actually metal stud frame too, which nothing else in my building is metal stud framed. So I don't know. That was before my time. Got some wood, got a ruler, got a marker. We're gonna mark halfway on the wood so that we go in the middle of it. Okay, it's 3 inches, so we're gonna go 1.5. And then we're just gonna transfer from whatever I did last time because that worked out well. So why are we putting this much effort into this? Well, the reason is because I have to drill this piece of wood, and then I also have to have drywall anchors behind it, and the drywall anchors get installed before the wood does. So I don't actually have to drill this wood. I do have to put the drywall anchors in the right spot, though. So we're going to get this piece of wood up first, because this one's kind of what requires greater precision, we'll say. and then we'll do the one in the wall, the third screw in the wall, because that's just gonna, I can install the drywall anchor through the strut. So we'll get the strut up mounted to this first. And if I recall correctly, I did actually do like a reasonable measurement for this gap. Oh, no, I didn't. Okay, that's cool. It's kind of close to a number, but it's not really. So let's get this, let's mark my wall for this. Level, I want a level. I mean, I could probably eyeball it, but I'll throw the old level on it. I already got the level out too. There it is. Hit it behind a piece of pipe. Big shocker there. So are any of y'all working on your own projects tonight? What are y'all up to? Level. Okay. So we're gonna go there, and we're gonna go there with our drywall anchors. Cool. Winding transformers. Oh no, kernel code. Kernel code got you down. Okay, we got winding transformers and writing kernel code. That's pretty good stuff. Vacuum, you vacuum. Yeah, vacuum, drill, yeah. What are the struggles of kernel code? That's some low-level stuff right there. Okay, where's my vacuum tool? There it is. The vacuum tool that instills way too much confidence and then makes me spill drywall dust everywhere. I love this thing. It's great. I mean, it is great. It is pretty great. How? Oh, this fit up here because there's not a 2x4 there. So this doesn't really fit here, does it? That's... Okay, that doesn't fit. New plan. So, Martin, what are the transformers you're winding? Are they for the scope or are they for something else? Okay, got attachment for the vacuum. Got a drill. Let's do this. Oh, contract client. That sounds like some fun stuff. What? Ah, this wall's weird. What are we hitting? Oh, there's wood back there. Okay, well, I guess we don't need that drywall anchor. How much you want to bet we're going to hit wood with that one, too? That'd be funny. Oh, shit. Whoa. That's... I don't think that's happened to me before. The drywall anchor kind of blew up. Gotta fund the SEM somehow. I know how that feels, Martin. I really know how it feels to gotta fund the SEM somehow. Huh. Oh. Oh. This has been patched. There's like the yellow mesh they use. So there's such a. What did they do? Why? Why is this way? Why? Why is my wall built this way? Oh, the autofocus is doing me dirty. Okay, I'll lock it in manual. Why is this wall weird? What's going on? So I was like, I know I use drywall anchors on the other one. But like, there's all this yellow stuff here. What's going on? What does this feel like? Ah, I guess that's wood there. That's also wood there. Well, we don't need drywall anchors. That's cool. Thank God it's not all spray foam. Oh my God. I have not found spray foam in this building, actually. There's probably some places there should be spray foam, come to think of it, but... Okay, well, that was not necessary. Cool. Let's put the wood up. And you're back. Cool. Still don't know why that camera does that. Somebody wants to buy me another R6. Or an R5 Mark II. Or, I mean, an R6 Mark II. But, or an R8. Or anything that's not a 60 would really do better as an A-cam. A Logitech C920 might do better as an A-cam. I should get one of those out. Okay, I got this marked. I'm going to drill all of that vacuuming and drywall dust generation. Completely unnecessary, but that's fine. We're going to get it done. Okay, manual focus locked. Thank you for letting me know that audio was struggling. Wait, that didn't work. That didn't work at all. Okay, so these screws aren't long enough to... Okay, we're, more plan readjustment happening. Let me get different screws, because we need longer screws. Man, this one's really throwing me for a loop here. Those are drywall screws. I'd rather use, like, deck screws. Let's see here. What do we got? We got 2-inch SPAC multi-material construction screws. I like the sound of that. You could do 3-inch ones. I think 2-inch will be plenty, though. These are T20, though, so I need to find a T20 bit. But, yeah, these are SPACs. I think these are number 10. Yeah, these are number 10. These are some good screws. I like these a lot. So that should, that's only going to bite a 1/2 inch. I think we're actually going to go deeper than that. I got 3-inch. Yeah, I'll do 3-inch. What are these? Are 3-inch number 10? Yeah, 3-inch number 10. Love it. SPACs, 3-inch number 10. I love the SPAC screws. I use these all the time. These are good stuff. Okay, so we'll get some screws out, and we got to find a Torx bit. which should be like right here, basically. You know what's unfortunate is that while setting up for this stream, I noticed that my my Torx T20 or a Torx T20 on the ground. It's like, oh, I should pick that up. But I was like, no, I'm in such a rush. I'm gonna just keep going. And then here I am needing my Torx T20. So I found an extension. Oh, I got a container of short T20s, but with the extension that'll work through this strut. So that's good. Ta-da! Ta-da! Get our drill set up here. Oh, don't fall, please. Oh, actually, I gotta put the washer and the strut on too. That's important. Okay, we got a washer, we got a Torx, and then a piece of strut. There's my strut. Is this the one we want to use? Oh, there's a rusty spot on this one. Let's get a different one. This one looks good. Kind of. This one looks really good. Cool, let's do this one. This one hasn't been filed. Have any of these been filed? Well. Oh yeah, this one's been filed. Cool. I think it has. Yeah, this one's been filed. Sweet, let's use this one. Okay, there we go. Un-Artos, oh no. Oh no. Un-Artos is pretty funny, actually. Like, was that intentional or unintentional? Okay, strut is on the wall and it's crooked, but that's fine. We're just still adjusting things. Okay, strut is level. Other things are not level yet, but. Okay, strut is now level, but we want strut lined up left to right correctly, and I think we're too far over to one side right now. Okay, we'll just base it on where this line on the wall is. Yeah, so you move it to the left a little bit. Favorite hammer right here. Autofocus still messing with me? It is. Good morning. We got everybody here tonight. Okay, manual focus it is. Come on. Oh, that left that behind. That's funny. High torque. Oh yeah. We don't even need the third one, but we'll do it. I mean, actually, so here's the problem with doing a third screw is that with like how this is working out, there's actually a pretty substantial gap behind the wall. We'll do a washer on both sides of this one because there's like actually kind of a gap here. I don't want to like pull the drywall out really far, so. Good morning, Peter. Hope you're having a good Wednesday morning, I think, if I understand how dates work correctly. No guarantee I understand how dates work correctly. Yeah, I think we'll go ahead and do we'll do a drywall anchor here, and then we'll do a spacer, so that we don't suck the wall out. This building is not square. Well, I mean, the building's pretty square. The building itself, the four concrete walls, those are pretty darn square, fortunately. Everything else, it's in those walls. Not so much. Well, some things are, some things aren't. My first shop, the four walls weren't square, so. Oh, come on. What's this one being weird for? Not having it. Jeez. Okay, one more try with that fun. Right. What is it? What is that? Okay, it is just drywall. It's just drywall with like extra particle board or something. Let's refocus because I think I shifted it. That focus locked. Hey, we successfully installed one drywall anchor. Doing great. Doing amazing. So I'm realizing that if this piece is sticking out like this, then that's going to, of course, cause problems with our other one, too. Why is this happening? Are those different heights? What's going on? Actually, what I'm going to do is I'm going to put a spacer on this side too, because I want the strut to kind of come out like that, because I can just see that it's kind of sticking out like this in a weird way, and I don't like what that's going to do to how I mount all the valves, because it's not on the same plane as this one. I've created a new plane. Wrong drill bit. So put a washer behind. Okay, not that one, because this is the one, this is the washer that got warped. Man, we had that so close and now we're pulling it all apart and... Bye-bye, washer. That looks pretty good. Let's tighten that down, see how that feels. Oh, derp. Forgot the washer. Well, that screw's never coming out. We managed to break a T8 bit. That's impressive. I haven't done that. Huh. The rest of that T8 bit is stuck in the screw head. I think you can probably see that it's like stuck in there still. Well, it's tight. Not happy with it. It's not. It's close enough to being on the same plane, I guess. I want to, well, what I want to do is I want to put another washer behind that side, I think. Huh. I don't know what to do right now. I don't know what to do right now. Because that's not going to come out easy. Let's just torque this side down, and maybe it'll level it out. That is cursed. That's very cursed. That's quite cursed. I'm not a fan of how cursed that is. That's annoying. It's a torque spit. It's supposed to be fine with torque. It's like a brand new one, too. This isn't even an impact driver. Let's just screw this side down and, well, let's push on it and see what happens. Yeah, you know what? If we torque that down, that'll suck it in a bit. Proximity to clown room. Yeah, proximity to clown room is definitely what's going on here. You're all just here to watch me suffer. That's what it is, isn't it? I guess me suffering is more entertaining. Oh, yeah, that sucked it in pretty nice, actually. Okay, we can proceed without messing with the bit that's stuck in there. Darn it! Come on, screw. Thank you, screw. Yeah, that leveled it out. We're good. I'm happy with that. Is it level? I wonder if it's level. Yeah, it's level. Cool. We can ignore the cursed one. Damn, working on the Mac kernel. That's crazy. Let's see here. We got the strut up. Look at the strut. Isn't that great? Strut. So it's going to look something like this when we get this up here. It's that all making sense to y'all? Y'all got any questions? Y'all got any ideas, comments, concerns, suggestions? Okay. The level does not say that it's crooked. The level says it's good. Unintentional, these, yeah, this is indeed an unintentional security bolt. Okay, so because this dimension, how wide this is going to basically determine everything else. I think our next course of action here is going to be to go ahead and fabricate the new one of these that doesn't have the gap issue. Yeah, the level on the camera does indeed say that it's not level. Here, I'll put you straight on with it. And then, there we go. Okay, so I'll show you why we're remaking this part for those of you who are just tuning in. So we've kind of got a voiding issue under here. So the piece that I use between the union and the T, that's the T, that's the, you see how the union and the T are right up against each other? That's because the piece was a little bit too short. So there's a void back there. And I don't have any voids like that anywhere else in the piping. It's just going to kind of like trap stuff. So I don't really want to deal with that. Yeah, I got a flow meter I'm going to be putting on this one. That's all going to be going kind of like down here below. The flow meters are going to kind of be ad hoc per microscope. So I'm not integrating the flow meters into the parts of the tubing that's kind of permanent. Because the flow meters will kind of ship with the microscopes. So everything that's below these valves ships with the scope. And above the valves is kind of permanent. And the chillers also are going to be shipping with the scopes. So that the scope is like tested with its chiller. So they're kind of a matched pair. So same thing for the flow meters and filters and stuff. At least that's the plan. So cool. So we need to make some new. We need to glue some new parts together here. So we need 2 unions on a valve. We got that right there. Let me grab some T's. Wrong bin. Let me go to the other bin. Okay, we have parts. Where do we want? Okay, so the microscope itself actually, or in the case of this microscope, the microscope does have a, it has temperature monitors on all of the, well, yeah, it has temperature monitors on all the electronics. The turbo pump has a temperature monitor. The column doesn't have temperature monitors, but everything is in one cooling loop. So there's temperature monitors in all the circuits. And then in addition to that, there is an adjustable flow switch in the microscope. So the microscope will automatically turn off power to water-cooled subsystems, which is lens driver, deflector driver, stage driver, yeah, stage, lens, deflector, turbo. I'm missing one. Am I? There's 2 lens boards, that's what it is. So all of those will turn off, and then the DC power supplies on this unit are not water cooled, so it doesn't have to turn the whole microscope off. It just turns off optics and stage and that stuff. And then the turbo pump doesn't need to be water cooled most of the time. the turbo pump only needs to be water cooled when you're doing like plasma cleaning or it has like a really high gas load. So it's fine if it loses cooling because most of the time you're not plasma cleaning. And the software, the turbo pump temperature is a software-based interlock, I think, actually, but the pump has another way. Like if the pump actually like stops pumping, then the hardware vacuum controller will stop. But if the pump just gets warm, and the software eventually will try to stop it. But if the turbo pump gets warm enough, the turbo pump itself will shut down, and then when that happens, the vacuum controller will become aware of that immediately. And the vacuum controller is FPGA based, so I guess you can kind of call it hardware. It's not really like firmware. For the firmware, call it software, I think. But yeah, the Joule DP warm-up sensors is supposed to basically be, I think it's a 60-degree or 45-degree sensor, and it's on the lowest coil of the lowest like, water cooling coil of the diffusion pump. So that actually heats up and shuts off within 5 minutes. And I think you usually I time it at like 2 to 3 minutes between loss of cooling and the diffusion pump thermal switch tripping. If it's taking longer than that to trip, there's definitely a problem. The pump is designed so that the thermal switch is positioned on the pump such that if it does heat up, it will heat up before parts of the pump that would be bad if they heated up. So it's actually pretty resilient. What's not resilient to is a partial loss of cooling. Like if the water cooling goes from like 20 degrees Celsius to like 45 degrees Celsius, the microscope might not shut off because of that. It's kind of like borderline. But the way Joule accounted for that was with the water chiller that they specified for that microscope. It had a over temperature cutoff. So if the water chiller detected that it went over temperature, it shut the whole chiller off, and then that really quickly would cause the thermal switch on the diffusion pump. The thermal protections on the diffusion pump are pretty robust with like where they are on the pump, which is nice. And the pump has got like a lot more thermal mass and is made out of a relatively thermally insulating material. So it's usually pretty resilient against loss of cooling incidents. It's partial loss of cooling that it struggles with. So that's why you're supposed to use a chiller that's interlocked against that so that it just stops flow completely if it gets like too warm. Yeah, if your DPs are getting super hot and nearly burning up, there's other things you should be evaluating because they are designed better than that, fortunately. There's a water cooling info dump. Okay, where should I do this? A table would be really convenient right about now. I don't know if I have any clear flat surfaces. I can make one. I'll make one. That's what we'll do. Let's see here. Why is the angle grinder still out? That was from when I was doing the floor. That doesn't need to be out right now. I mean, I'm not going to put it away. I'm just going to put it on another flat surface so that I can get this brought over to the area where I'm streaming faster because we're making choices that are expedient. Hey, look, another T20. I wonder if that one would have broke. Why is the Ryobi battery out here? I have like 2 Ryobi things total, and none of them are out here. But feel free to ask any more water cooling questions. I love answering water cooling questions. Water chillers are one of my favorite things. I mean, hey, that might just be a coping mechanism for having to deal with them so frequently, but I think they're pretty fun. I like making them really happy and really robust. Hey, look at this table. We got a whole table here. Isn't this great? Let's see here. Don't need that on it. You don't need that on it. I mean, I guess I don't need to clean the bottom up. We're not using the bottom. You should definitely intentionally test your chiller interlocks on the Joules. Shut off cooling water, start a 5-minute timer. If the microscope doesn't shut down within 5 minutes, there's a problem. Always test your interlocks. Look at this, we got a little table to do our glue up on. Isn't that fun? Let's wipe that down real quick. The history of the Joule diffusion pump design, including the logic that went into its overheat circuitry, is... Oh, where did my camera go? Oh, I unplugged the USB cable. The history of the Joule diffusion pump, including its thermal overlock circuitry and logic, is described in the History of Joule Vacuum Systems book by that one Joule engineer. I posted a link in the Discord to it before. That design of that pump originated because they were trying to use the Edwards pumps originally, and the Edwards pumps were a little bit lightweight, so they actually were like they were putting on a microprobe, and then they noticed that like the microscope was vibrating. Again? Did I unplug it again? They noticed the microscope was vibrating, and they eventually figured out that it was actually... Okay, we're just losing all the cameras at the same time. They actually discovered it was the diffusion pump itself that was causing the vibrations. So that's what led them to design their own pump, was they needed a heavier one. They did a good job positioning the sensors. So they got two sensors on it. They got the warm-up sensor, which is mounted to a non-water-cooled section of the pump. And that's so that I'm just going to raise this tripod a bit here. That's so that it's on a part of the pump that gets warmed up by the oil jet spray. So the pump doesn't show being warmed up until the oil is actually spraying. And then the overheat sensor is attached directly to one of the cooling coils so that it only would warm up in the instance where the cooling coil itself is warming up, and that would only happen if there was a loss of cooling water. So okay, check this out. We got a whole little setup here. So oh, I can imagine interlocks on MBEs going bad. Is that like flow interlocks on the E-beam crucibles? So you just like completely melted the crucible or the gun? MBEs are scary. I've been around MBEs a little bit, but not enough to like have like melted something on them. I feel like that's kind of inevitable. Why is this being weird? Well, that doesn't matter. Okay, let's measure depth on our fittings here. Here, I'll do the cooking show style. I'll be across from the table. So the DP warm-up sensor on the Joule diffusion pumps is actually conservative enough that if you have too much cooling water or too cold of cooling water, or both, the pump will never actually get to the warm-up point. And that's annoying, so. Okay, y'all, do not let me forget to put the union part on. That's, we need to not forget that. That would be bad. Let's check the depth on that. That's 1 1/16. So 2 of these, 1 1/32. So 2 of these is going to be 2 1/16. How much space do we want to add? Let's do approximately a 1/4 inch gap. I don't know, how do y'all feel about that? So we've got our union, right? This one, just throwing things. This one has got no gap, right? What do we want to do for our gap here? I want a little bit of a gap. Like, do I want a 1-inch gap? But the wider I do it, the more width of the strut is going to take up. So, not quite sure what we want to do there. So we'll probably do 1/4 inch, unless anybody else has got any other ideas, or better yet, other things to consider while doing this. And I probably should be giving you all measurements in metric too. So what's a 1/4 inch? We're going to do the really stupid way of converting. About 1 centimeter. So I'm thinking we're going to do about 1 centimeter gap, or just under 1 centimeter. Probably under 1 centimeter, actually. Because we just need some amount of a gap. I don't really see any advantage to having a bigger gap. Right? Like, so something like that. As long as there is a gap, we'll know that we did get the tube pushed down all the way in both directions. So I'm going to start getting set up for that. Let's get the fume extractor moved over here. The ladder's right in the way. How do I want to do that? Let's bring the ladder this way. And this tube is in the way as well. Beep, 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 beep. I've been like lifting this thing up kind of, or pushing it away from me with like one part of my shin. And that was the first time I did that tonight. And I was like, oh, I could tell that I've done this a few times recently. So we need to stop moving the ladder like that. Nice. Yeah, audible alarms are pretty good. I mean, except in the middle of the night when nobody's there, you know? Like, you really do gotta trust the interlocks. But preventing the, like, operator error, that's good. The other spec on the Joel specified Haskell chillers that were supposed to ship with the microscopes originally was that they had an AC interlock on it. So it would actually just, you'd have a cord that plugged into the chiller, but also plugged into the microscope, so the chiller would automatically turn on whenever you were running the microscope. That's a really good way of doing it. I'll be doing a stream on Haskell chillers here soon, because I've got a Haskell chiller that needs some help at the moment. So here, let's set this up some kind of pointing towards the camera more. That's a little bit more natural. Then I have the light pointing the right way too. Can I stop the aperture down? Let me set this more to manual mode. Oh boy, okay. All the way manual. Wait, really? It doesn't... That's annoying. Oh, that was maximum ISO. That's funny. Okay, well, 1/30th of a second shutter. And that'll let us stop the aperture down to like 8. And there's no exposure meter in this mode. Wow, this is a really well thought through mode cannon. Okay, I like that. Okay, let's glue some parts up cooking show style. Oh, that's way too overexposed. Okay. There we go. Cool. So we're gonna do 2 1/4 inch pieces. We'll just set this to that. Okay, setting this to 2 1/4 inches. Let's see here. We like this piece of pipe? No, that's not a very clean one. That one's got one end's got a pretty clean cut on it, I think. Yeah, it's got a pretty square cut on it. Cool. So let's mark out 2 1/4. Did y'all come up with any reasons to do more than 1/4 inch of a gap? Stainless pipes dissolve in water sometimes. Yeah, stainless isn't necessarily completely immune. It's still a good idea to just like not mix metals in cooling loops, but people feel like if they use stainless, they can get away with it, and that's not necessarily true. Okay, we're gonna go in the middle of our mark. There we go, that should be 2 1/4. Well, that kind of deviated a little bit, so that might be just slightly longer. That's about a 1/16 long. That's acceptable. Some of that will come out when we file it. Actually, that's really crooked. I'm not happy with that. That one's gonna void. To the trash. I'm gonna grab another piece of pipe. Oh, I already have a piece of pipe. There we go. Stagnant water, 900-degree heat next to it. Oh my god. Oh boy, MBE is exciting like that. Oh hey, this one's already filed. Okay, we'll do that because that's just ready to go. Less than a minute. Yep. So there was no flow interlock on that system? Or was it just like one part of the cooling loop? Oh, and I adjusted this. Okay, let's readjust this back to 1/4. So was it just like one part of the cooling loop didn't have a flow interlock and like that one part clogged, or did the chiller fail, or? We saved one a second time. Oh man, you were doing chemistry in there. If you're gonna, man, that's something that doesn't happen in SEMs, just like casually getting up to like 900 degrees like that and making your cooling water instantly turn black. That's insane. I bet you all can see my marker. There it is. Okay, we got that marked out. Let's cut this cut. That's pretty good. I'll take it. Okay, so that's our, just double check. That's 2 1/4. Cool. So there's part number 1. Cut a second one from this piece. That one kind of deviated more than I would have liked. Let's see if we can't clean that up a little bit. Well, I've cut off most of the high spots. If I just cut off one more high spot, we should be good. Okay, one more. Okay, that cut the high spot off. Cool. There was an interlock chiller fail. The interlock is just like notification of 1 to 2 months of downtime. So does it does the interlock like not shut it off, or does it just like not cool off fast enough? Like when you got that like stuff that's that hot, I guess it just takes a sec for it to cool down. Okay, there's our 2 pieces. So we don't need this right now, so we can move this off to the side. Let's bring the extractor up. Let's move stuff we're not using out of the way. Basically just so we don't suck anything we don't intend to up the extractor. Okay, let's turn the extractor on. Okay, extractor's up. So first thing we're going to do is clean these up with the file, chamfer those edges. I guess it's actually over here. Yes, it is over here. And my glue is also over here. How do we like the cooking show so far? How's that going? Oh, my, that's terrible. That's really bad. Everything about that is bad. Oh my god. None of those are good failure modes. It takes too long to cool, and it's an aluminum cell, so if it cools below 700, then it solidifies and expands as it solidifies, cracks the crucible, and dumps the remaining molten. That's so bad. Like, what are you supposed to do with that? So how do you not crack the crucible when you cool it down? Do you cool it? I presume you cool it down. I should really get tools for this. That would make my life so much better, but I'm also pretty close to finishing plumbing for now, so. Epitaxy is such a fun field. Did you do it in a university environment, or where did you get your MBE experience? Okay, that one's done. Oh, man. That's funny. That's really funny. Oh, hey, that side's already done. Cool. Oh, the ID's not, but we'll get that done real quick. Okay, got these all cleaned up real nice. Okay, let's, yeah, you have to live without it until everything is broken. Oh, man. I love UHV systems. They're so much fun. They are so much fun. Okay, I think we're ready for that glue up. So we're gonna do T's first, then we're gonna do unions, and we're not gonna forget the outside of the union. Y'all cannot let me forget that. So, how are we gonna do it? Let's get our cans open. Let's shake this one. Okay, so what are we gonna do? We're gonna take this piece here. We're going to do primer, primer, cement, cement, and then we're gonna put them together. Any questions? Oh, that looks real good. Ah, I like that. Ten. 9. How long are you supposed to hold this together for under pressure? "30 seconds. Let's make sure we got enough distance on that. Yep, we got enough distance. Cool. I like it. Okay, so let's practice that one more time. We're gonna do primer, primer, clean it, solvent, solvent. Cool. That looks good. Oh, man. Oh, I lost the camera. Okay, I'll get over there after I get this one glued. Yeah, the bake out part is really annoying. UHV is just like that though, and UHV on really big chambers is kind of a challenge. Cool, we're back. Okay, round 2. So what we're gonna do on this one? Okay, so we're gonna go primer, glue, quarter turn. Yeah, we can do that. Oh, I'm holding that one backwards. There we go. There we go. And, oh, we got too much came out on the inside there. Why'd that happen that time? That's weird. Okay, let's get that cleaned up. Huh. It didn't happen on the T side. All right. Yeah, no, T side's good. Probably just got a little bit too much glue on the inside. Is that one good? Yeah, that one's good. Okay, but that cleaned up really well, so I'm happy with that. So there's the new one with a slight gap assembled properly versus the old ones without the gap that were not assembled properly. So there we go. Sure we got enough distance on this all around. Sure do. Let's get this one done too. Okay, so we're gonna go primer, solvent, cement. Not as much on the inside that time. That should take care of it. Oh, that one. Okay, nailed that one. Cool. Love to see it. We might come back and put a little bit more to kind of fill that gap. It's amazing like how pure stuff has to be when you're laying down like tens of atoms of thick layers. It's pretty wild. There we go. That's two of them. Love to see it. Cool. So I don't need these ones anymore. I can put those away. Okay, let's get ready to do the, oh, we're missing an O-ring on this one. Oh, where did that go? Crap. Found it. Okay, cool. That could have been worse. Okay, so now we're gonna do the next part of this. Maybe. Do I have the parts? I do have the parts. Okay, yep, we got the parts we need. That's good. Come on, stop that. Okay, so we're gonna go on to our next part of assembly here. So next we're gonna glue on these valves. So this is our crossover one, right? In the middle there. And now we're gonna glue these two in. So these ones are gonna need a little bit longer of a piece of pipe because these ones are gonna have a strut clamp in the middle. Okay, so this part here is 1.5 inches long. So we're gonna need to be probably 4 inches. Just give it some space. We could do 3.5. That'd be a little bit tight. 3.5 would work though. But no, 3.5 would not work. Let's do 4. Let's do 4. So that's too short. Okay, let's find some pipe to cut. There's some pipe to cut. There's some more pipe to cut. Oh, there's a good piece. Let's use this piece. I like this piece. No, we'll use the short ones up. That makes sense. Oh, wow, what did I do to my calipers? Okay. Whatever, calipers. We won't use calipers tonight. We'll do how I've been doing it. Okay, set that to 4. We got a good square end currently. Yeah, that's a good square end. Okay, we got that marked to 4. We'll get that cut. Okay, let's get one more 4-inch piece measured here. Okay, right in the middle of the mark. Let's get these cleaned up. Okay, I got one end cleaned up. Let's do the other. Okay, that one's cleaned up. Let's get our next one cleaned up. Okay, that's number 2 cleaned up. Cool. Let's do, I think T first, then Union. Yeah, that makes sense to me. So for those of you just joining, we're doing some PVC glue in here. Getting ready to put some stuff up on the unistrut here. Not sure if we'll get everything put up tonight, but we'll definitely get this assembly done tonight. So we're going to be putting that piece into there. We got our glue mixed up. Let's get our primer out. So we're going to go... So we're gonna go primer, primer, glue, glue, in quarter turn. Okay, that's the glue. And quarter turn. Oh yeah, that looks good. I like it. Hold that for some number of seconds. No, I really like getting the fundamentals done. Like, this is infrastructure. Once you get infrastructure built, you just keep using it. Every time you use it, you're so satisfied. It always takes way longer to build infrastructure than you think it's going to, but... Cool, that is unobstructed flow in that. Nice. Okay, so let's go solvent, or sorry, primer, primer, cement, cement, quarter turn. Okay, another good one. Okay, so very important, we need to not forget the unions. Where's the union? Okay, solvent, or sorry, primer, cement, cement. Yeah, a little bit coming out on that one, but we can take care of that real fast. These unions are definitely the hardest ones to assemble with no defects. Okay, we're remembering this part, very important. So we're gonna do primer, cement, cement, quarter turn, inspect for it sticking out too far, pushing in too far. Yeah, got a little bit on the inside again, but real easy fix. Okay, that's pretty much this assembly done, I think. So I think we might wrap it up here pretty soon. These joints are not fully cured yet. They're cured enough to hold themselves together, but they're not actually cured. So what we're going to do with them next is going to definitely put some force onto them. Because we're going to be using this basically as our gauge. Like however wide this is how far apart these tubes are going to be. So we're going to be definitely like clamping and sticking tubes in and out of these. I need to clean the lid of that one up, otherwise it's not going to close easy next time. Cool, those two are done. Let's get this can cleaned up so that it's going to close easy next time for us. I'll use a paper towel so I don't have to throw that away when we're done. Well, that was a good stream, I think. I did want to get further progress done on this, but it's a bit later than I thought it was going to be, and these need to cure for some amount of time before I use them, so... Oh, that's just putting all kinds of gunk down in there. We don't want that. That all needs to come out. All these boogers that form in the inside of the can here, they get in it, and then I can, I'm like dealing with it when I'm trying to put it on the joint. So I'm trying to just get this can cleaned up before I put it away. Oh, that's a big, I did not think there was gonna be that big of one in there. Oh my God. Okay, that's a lot cleaner than it was. I'm happy with that. Yeah, check these out. I like them. So that's going to go in the middle there, and then we're going to get one there and one there. Look at that. Check that out. I like this cooking show style setup we got going on here. This was fun. I want to do more streams on preparing some samples too, just looking at stuff under the microscope. So this type of setup I think is going to come in handy for that. So I should remember to have like a clean surface before I start streams in the future, so I don't have to clean it off midstream. Here, I'll show you how these parts are curing. So if I like touch this stuff here, it's still really soft. Yeah, we're wrapping up here. Yeah, this is way like it's not soft enough that's sticking to it, but it is soft enough that's kind of like squishing. So that's a little bit too. That's not. Oh. Okay, I accidentally touched that with the union. Don't want to do that again. So that's not really strong enough for us to mount up yet and use as our spacer for everything else. So. I don't know if that camera's level or not. Oh, it's super not level. Well, oh, it's tipping. Okay, let's not do that. Well, I think with that, we're gonna say goodnight. That was a really fun stream I had doing with y'all. Let's not overexpose that as much as it is. Maybe not underexpose it too, though. There we go. That was a pretty fun stream. We got some strut up. We got a camera that's not working. So we got these things glued up. They're gonna cure overnight and be ready for some more strenuous forces to be applied to them tomorrow. But I'll kind of show you how these will go up carefully. So these are going to mount here. Our strut clamps are going to go on here, and I'll hold it all up, and I think it'll look pretty good. So anybody got any questions? Now's a great time for them, but yeah, I'm pretty happy with that. Yep, Flow looks unobstructed in all of these. Yep, flow looks good in that one and that one. Cool. Well, thank you so much for y'all for joining tonight. I really had a great time. I like seeing y'all coming back. It's fun to have a crowd here. It's better than doing this alone, you know. So always appreciate y'all showing up, and I'll see y'all later.